So thank you very much for joining our session and give a talk, a graduate skills talk. So I would like to introduce you. So Liam is a professor at the University of Edinburgh. And I've been told that Liam is very, very passionate about teaching and advising and also about writing. And that's basically what he's going to talk about to us today. So I'm really very excited about this because, especially as a student, I think it's very hard to write. Some are naturally better at it than others, but we all know how it feels when you are in a writer's block. So I hope you have some advice. So with this, I'll give the stage to you. Thank you.
Thank you, Stephanie, for the introduction. And thank you to all of the PLMWs for inviting me to present. I'll just try to share my slides. Is that showing up? I think it is. So it seems to be working.
Yeah, it is.
All right. And if I go around, yes. Okay, great. So hello, my name is Liam. And I actually was attending PLMW as a student not that long ago. So I was appointed as a lecturer in programming languages here at Edinburgh. And you can see my background is a much sunnier picture of Edinburgh than it actually is at any time of year. So I was appointed as a lecturer in 2020, and I've really been working a lot on things like temporal logic and property-based testing these days, although my PhD was on more formal methods verification-oriented work. But today I'm here to talk to you about writing, and a lot of my thinking on this subject stems from Larry McEnany's writing lecture series at the University of Chicago. You can actually find these online. If you just search for Larry McEnany writing, you'll find it on YouTube. There's several multiple hour-long lectures on this topic, and these were really, really instrumental in helping me clarify my understanding of the role that writing plays in academia and how we can write papers that effectively communicate our ideas. So let's start with some definitions. What is a paper? What do papers do? Well, papers contribute knowledge. And knowledge here is defined as valuable information. So I'll come back to this definition later on, but I would say, well, to give an example, well, more of a counterexample, I did a little analysis and I discovered that the Racket code in its GitHub repository contains 438,573 opening parentheses, but only 438,521 closing parentheses. I do not define this information, which is new. I'm pretty sure that no one will have known this information before I just presented it. So it's new information, but it's not knowledge because it's not valuable. No one needs to know this information. And when I was a PhD student, which was not long ago, as I said, I was actually inundated with advice. A lot of the information that I got was not valuable to me. I was presented with a lot of ways to think about papers, ways to think about writing, and these ways weren't actually useful in helping me to develop my writing skills. So this is an example of something that I got presented to me in a compulsory course that I had to do on research skills when I was a PhD student. They presented a slide that looked like this. It said that the field of computer science, programming languages, whatever, can be thought of as like a jigsaw puzzle. And when we write a paper, what we're doing is filling in a gap in that jigsaw puzzle. Now, I don't like this view of knowledge because it supposes that just because there is a gap in our knowledge, that filling in that gap is inherently valuable. But as we saw in our example before, this statement about bracket parentheses is not valuable, but it is filling a gap in our knowledge. No one knew this before. So just because you fill a gap doesn't mean that what you have done is produce knowledge. I saw this model of knowledge as well, which came from Matt Might's Illustrated Guide to a PhD. And while it has a nice point to make, it also suffers from a little bit of a problem. What it's saying is, you imagine that the space of information is this big infinite plane here, and the circle represents the sum total of all human knowledge. And when we write a paper or make a research contribution, what we're doing is just pushing the boundary of that knowledge a little bit. And so over time, as people write more and more papers and make more and more research contributions, the total amount of human knowledge gradually increases. So why don't I like this model of knowledge? Well, what we're saying here is that the amount of knowledge is strictly going up, that humans have always accepted, like the knowledge that humans accepted has just gotten bigger and bigger and bigger. But this isn't really true. There's historical examples of things that were once considered knowledge that are no longer considered knowledge, like alchemy, for example, which is now thoroughly discredited. And if we return to our definition of knowledge, we said that knowledge is valuable information. Valuable to whom? Well, it's the programming languages community. It's made up of people, and these people are having conversations. They define what knowledge is, and they define what is valuable. So what we need to do when we write papers is participate in these conversations. These conversations are already moving the community in a particular direction. And what we want to do with our papers is change their direction a little bit, move them in the direction that we want them to go. So what we have to do is write a paper to influence the community. So we have to be thinking about readers. It's not about the process of writing a paper to summarize your research and talk about your contributions. What you need to be doing is thinking about readers and how to bring those readers along for the journey of your research. So how do we demonstrate to the community that what we are doing produces value? We need to demonstrate our value to the community in our paper. So the first thing we should say is, hey, PL community, I've read all your stuff. You need to say, I've read all your stuff, because what you're doing here is showing respect for your colleagues. If you don't read the related work in an area, and you don't understand the existing conversations that are happening in the community, then you can't influence them. Then from this point, there's two ways you can go. One is to say, and this is my contribution. Hey, PL community, I've read all your stuff, and this is what I want to do. But if you come up to a conversation that's already in progress, say at a conference, for example, a bunch of academics are talking in the hallway track, and you go out and join their group, and then you just start talking about your work without respect to what they were talking about already, then that's almost a little bit impolite. So what I think we should do is instead focus on something like this. We say, hey, PL community, I've read all your stuff, but there's a problem with it. I've found an issue. So forget about and. Let's only use but, okay? And then once we've discovered a problem, we have to show that that problem is worthwhile to solve. How do we add value to the community, right? We need to make sure that not only do we introduce a problem, but we also need to show that that problem causes an actual issue, that it actually has a cost. Or alternatively, we have to show that solving that problem would bring some benefit. So I've written two examples here of discussing the exact same thing that I was talking about before with the bracket source code parentheses. And One is the counterexample, and it's trying to do everything wrong here. And the example is how I would do this if I had to present this in a more effective way. So the counterexample is, an analysis of the number of parentheses in Racket source code was conducted. This analysis found 438,573 opening parentheses, but only 438,521 closing parentheses. Our new tool, WC, based on this powerful bracket counting technology, can discover such syntactic discrepancies easily over large code bases, making it a significant step forward. Now, there's many things wrong with this. The first thing that I would say is it's using passive voice in the first sentence. Now, a lot of people get told when they're learning about academic writing that we have to use passive voice whenever we talk about things that were conducted in the course of research. And this may be true in some fields, but it certainly doesn't seem to be true in computer science. And in particular, if the passive voice is making things a bit more convoluted to express or a bit unclear, then ditch the passive voice. And in general, a lot of these rules that we get taught about how to write well tend to be really more like guidelines. So please, in the interest of clarity, good structure, persuasiveness, and most of all, demonstrating value, feel free to jettison any rule that you are taught about writing. Now, the next sentence says, this analysis found blah opening parentheses, but only blah closing parentheses. Now, this is unnecessarily detailed because the point here is that there is 52 more opening parentheses than closing parentheses, but we don't want to make the reader do math. And then the next sentence is full of words to try to make the research sound important. Our new tool, based on this powerful bracket counting technology, can discover such syntactic discrepancies easily over large code bases, making it a significant step forward. When you use words like significant, new, you're trying to basically tell the reader that what you're doing is important. But that's not convincing. The way you convince the reader that it's important is you show that the problem it's solving actually causes a cost or that solving it has a benefit. So here's how I would express the exact same thing, but more effectively. We start by talking about the existing conversation that's going on in the community. So we say, compound expressions in Racket are represented as lists of sub-expressions, famously wrapped in matching parentheses. Okay, so we establish the existing conversation that's already taking place. Yet, we use words like yet, although, however, but to introduce some sort of contrast. And this is showing that there's a problem here. An analysis of Racket source code reveals 52 more opening parentheses than closing parentheses. Okay, so maybe there's a problem here. Now what we do is we show that this has some sort of cost. This means that either the conventional understanding of Racket syntax is incomplete, bad word, that's a cost, or that there are many syntax errors, that's also a bad thing, in Racket source code, right? So it's one of those two things. Our tool, WC, can find such discrepancies over large code bases, enabling such syntax errors to be rapidly corrected. So what we've done here is shown that we have a benefit from solving this problem. So while, of course, counting the number of parentheses in source code is not going to be publishable research in any case, you can see, I hope, that the right-hand example is much more effective at persuading the reader than the left-hand example, and convincing them that the problem has value. So let me show you another example, which is actually from a published paper of mine. Right. So a commonly used technique in independently typed programming is to encode invariants about a data structure into its type, thus ensuring the data structure is correct by construction. So this is talking about existing practices within the community. So we're making reference to things that the community already understands. Unfortunately, there's a problem. This often necessitates the embedding of explicit proof terms within the data structure, which are not part of the structure conceptually, but merely another but, however, those sorts of contrast words, you need these to establish the problem, supplied to ensure that the data invariants are maintained. Now we show that the problem has a cost. As the complexity of the specifications in the types increases, these additional terms tend to clutter definitions, reducing readability. There's the cost. Now we have the solution. we introduce a technique where these proof terms can be supplied later by constructing the data structure within a proof delay applicative functor. And then, the paper goes on. Okay, so this is the structure that our papers should follow, or at least my papers follow, and I hope that this technique is useful to you as well. You start by talking about the existing consensus within the community. Then you introduce a problem using words like unfortunately, however, but, that sort of thing. Then you show that solving the problem has a benefit, or that the problem existing has a cost. And then you show your solution. How do you deal with related work in this situation? Well, with related work, what you can do is use it to enrich the problem. So what I mean by that is you can cite related work to establish the existing consensus within the community, and then point out the problems by examining that related work critically. So for example, this is from an older paper of mine. While formal verification for file systems has seen a surge of activity in recent years, it has, however, not yet reached that same level of detail and assurance. This is from later on in the paper. So we had already established some background here. So while, however, not yet, these contrast words that establish the problem. In the most advanced and deepest of these verifications, Chen et al. Formally shows crash resilience of the FSCQ file system implemented in the Coq prover. So here, what we have to do is, when we're making reference to related work, and we're even pointing out problems with this work, then it's very important that we also acknowledge the things that work has done, which are good. It's not very nice if you just constantly criticize and point out all of the problems without also acknowledging the legitimate contributions that work has made. So we say in this paper, in the most advanced and deepest of these verifications, to indicate that this paper has done good work, but there's a little bit of a problem. You have to be respectful when you're talking about related work. Even this verification still relies on generating Haskell code and executing it with a full Haskell runtime at user level. Once again, we point out the problem using words like even, still. This proof crosses an important barrier in formal verification, praising the related work. However, contrast, the trusted code base is still huge, the runtime is larger than the file system, the code generation step from Coq is unverified, and the semantics of the target language Haskell are complex and informal. That's establishing some cost here. While certainly an impressive result, praising the related work for high assurance systems on potentially resource-constrained devices, this is not yet good enough. So what we've done here is use the related work to show how the problem is still here, that it's and to enrich and add value to solving this problem. Okay, so that's the first part of the paper. We establish that there's a problem, and we talk about ways in which we can solving the problem would bring a benefit, and that the problem itself has a cost, right? Once you've done that, the next thing to do is to present your solution. So when you're doing your research, you might go on a little bit of a journey to arrive at this solution, right? It's very rare that you see a problem, you solve the problem, and then you write up the paper, and that's it. That's not how research normally works. We take many wrong turns and false starts, and we go in this sort of random walking through the space of information until we finally arrive at a solution to our problem, right? And a lot of people will say, okay, but when you write the paper, you don't present any of these wrong turns and false starts, and instead you just present, a direct line from from the problem to how you solved it. But I don't agree with this perspective entirely. And the reason I don't is this is entirely talking about the author and their research and not talking about readers. It's the PL community that's going to be consuming your research. And so what your solution, your explanation of your solution needs to do is not tell the community how you solve the problem, or at least not directly. what it needs to do is convince the community that what you have done solves the problem that you have posed. So it's a different thing. There's a sort of two different purposes at work here. There's a distance between these two vectors, right? And what we want to do is make this angle theta as small as possible. We want our paper to bring the community to our research. So it's not a recount of what was done. What you need to do is convince the reader that the work addresses the problem. Okay, so let's suppose that we try to write a paper and it gets a negative review. This will happen to all of you. It can be quite soul-crushing at first. You do get better at dealing with it, but I mean, I'll be honest, even now when I get my papers rejected, which does happen quite often, it still hurts a little bit. And it's worth being okay with that and taking the time to process that in the way that you need to. But anyway, let's suppose that our paper gets a negative review. The review says, this paper doesn't seem important. The work presented lacks novelty. The explanations were confusing and difficult to understand. So a lot of the time when people see a paper like a review like this, what they try to do is use those words that the review used, important, lacks novelty, and then just say in the paper that these things are actually there. So you say, this paper presents a new and important contribution. You're just telling the reader that it is actually important and that it is actually new, despite the fact that the review seemed to think otherwise. This doesn't work. Of course, it's not convincing to just tell someone that something is new. You have to establish that the problem is valuable. And if the problem is valuable, then what you will be doing is new. Because if the problem has already been solved, then there is no value in solving it again, right? So novelty is subsumed by value. If you can show that the problem is valuable to solve, then you will have already, compared to related solutions or related work, you will have already established that what you're doing here is different from that. Because otherwise, there would be no value in solving the problem. The other bad idea, and this happens a lot, and it even happens to me quite often, is I think, if I got a negative review, they mustn't have understood my paper properly. So I need to add more explanation. I need to explain more detail and more information about what I did so that they understand better what I did. And then because they'll understand what I did, they'll inherently see how great my research is, right? But this is also a very bad idea. You don't just explain your research. You don't add explanations just for the sake of explaining things. The only explanations that should appear in your paper are those that will convince a critical reader that the problem has been addressed. And what I mean by that is a critical reader is someone who is looking at your paper and trying to find any threats to its validity. They want to see, is this paper actually addressing the problem that they've set out? If so, how does it address it? And how well does it address it? And they'll be very careful to look at that information and try and come up with any reason to, well, they may not be coming up with reasons to reject your paper. Sometimes reviewers work in the other way, but anyway, they're still trying to find out, does the paper support the claims that it makes? Does it solve the problem that it poses? So they're being very critical about that. So what you need to do with your explanations is convince them that that's what you've done. Okay. Now, that's actually all I have, but just to summarize all of the takeaways here, the first thing to think about is readers. They define what is valuable. And currently, that group of readers is the PL community, and the PL community is mostly white, mostly male, although that's changing in a more diverse direction, hopefully. And because they define what's valuable, you must always be writing your papers with respect to their perspective. It's not just about what you did, it's about bringing the readers along for the ride. You demonstrate value in your papers by posing a problem, but is better than and. You show the problem has a cost and that solving it has a benefit. You use the related work to enrich the problem and to compare to existing attempts at solving similar or even the same problem. And then when you're explaining your solution, you only explain to the purpose of convincing a reader that you have addressed the problem, not just filling your paper with technical detail for the sake of it, right? Now, that's to say, don't just omit all technical detail from your papers, because if you do that, then a critical reader will say, well, they omitted all this technical detail, so I can't tell if they've actually addressed the problem they say they have, right? So that's why we have technical detail in our papers, but it always should be with the purpose in mind of convincing a reader. All right, that's all I have to say about it. If I'll just add one little addendum, which is if we're talking about the actual craft of writing with respect to grammar and syntax and stuff like that, a lot of the time people recommend style books like The Elements of Style, Strunk and White, and those sorts of books. They're fine, but always, as I said before, with respect to rules, try to think of any rules when it comes to the structure and the style of writing to be really more like guidelines. The first thing you need to be prioritizing when you write a paper is value. The second thing you need to be prioritizing is persuasiveness. The third thing is clarity. And the fourth thing is structure. Okay? Those things are the most important. And if you need to discard any particular rule that has been imposed by some style guide or something similar in order to achieve those things, then do so. All right. I think that's all I'll talk about today. But by the way, I have a fully funded PhD place available and I'm looking for students. So if you're interested in any of the work that I do, please let me know. I just thought I'd throw in an advertisement at the end. Thank you.
Thank you so much, Liam. And thanks also for sticking perfectly into the time limit that we set. So we have now about 5 minutes left for questions. So currently there's no question in the chat, but I think the microphone issue should have been resolved by now. So maybe we can get some question from the audience.
Excuse me, can you hear me?
Yes, we can.
Yes.
Okay. So you mentioned that the readers define what is valuable in research. So imagine that someone works on a specific problem that believes it is interesting, but the community may prefer work on other problems because of different reasons. I don't know, personal research taste, demands in industry. So what is your opinion about this scenario? Should the person continue work on the topic or change the direction?
So I don't think that there's ever anything that is like, unless the work has been discredited, it's very hard to actually have an area where the community really is just not interested in it. Quite often, a lot of people, like I have spoken to academics in the past who have told me, oh, you know, the community doesn't care about my work and they don't want to publish it because they just don't like the area that I'm working in, right? Or they're not interested in these papers. Now, that's actually rarely the case. Usually, if I look at their work, what it tends to be is either they don't really engage with the work that's already been taking place, or they are unnecessarily and overly critical of other work that's been taking place. So people feel insulted. These are the two things that seem to happen when people say that their field is not respected by their community. Now, that's only anecdotal. Of course, I don't have any proof of this, but I think if you make the case well enough that the problem really is valuable and worth solving, then even if it's sort of out of left field or not really related to the existing conversation, people will find that interesting and valuable.
Thanks a lot, Liam. We have 2 more questions in the chat. I think there's a way for the student volunteers to show that on the screen. Yeah. Here we go. So any tips on revising a rejected paper given reviews?
Yeah, I mean, this is always a challenge. If you think that, so one thing I did mention in the talk is when reviewers reject a paper and you feel like the reason they rejected it is because they didn't understand it, that is not a sign that your explanations are unclear, although they might be. The other thing that is possible is that you didn't demonstrate value enough. And the reason I say that is, if you are reading a paper, and I've felt this as a reviewer, if you're reading a paper and you don't really understand what the problem they're trying to solve is, when you get into the technical detail parts of the paper, you just give up. You stop caring about it because you don't understand what they're getting at. So sometimes it's actually just worth framing the problem really, really well. And then once you get into the technical details, they'll put the effort in to understand those details rather than just give up straight away. The other thing is, other reasons that papers might be rejected is just sometimes you are submitting to a very competitive conference and papers get rejected from those sorts of conferences. And when you get the suggestions for improvement, you should always take them seriously. Sometimes I've reviewed papers multiple times that have been resubmitted to multiple conferences, and I find in the 3rd submission or something that the paper didn't address the comments that I had made in the previous times I've reviewed it. And this is this feels, when you're reviewing the paper, quite almost insulting, in the sense that you came up with a suggestion for improvement and it wasn't taken into account. So always try to take into account all of the reviewer comments. If they are unnecessarily critical, then take the time to sort of work through that emotionally, but still see if you can find some valuable suggestions for improvement there. But always take them seriously, try to incorporate them in your paper, and just keep trying, just keep plugging. That's the only advice I can give on that.
So we have a couple of more questions, actually. So could you put Joe Paulus' question on the screen? It is tips explaining concepts in a simple way for the reader. I think that's a hard question. So let's see what Liam has to say about that.
So yes, that is a very hard question to answer in general. One thing that I found is that I have, since I was a PhD student, and even before I was a PhD student, I did a lot of teaching. And I think if you're a student, a PhD student now, and you're not really doing any teaching or teaching assistance or anything like that, consider doing it. And the reason I say that is, if you get practice working with students who do not understand a topic that you know very well, and you figure out ways to explain those topics to them, you'll learn the techniques that you need when expressing your research as well, to explain complicated topics in a simple way for a reader. So I think teaching is actually a very valuable component to my research, because it helps me to refine those skills. The other thing I'll say is, when it's talking about mathematical concepts and things like that, notation is very important. So if you can come up with a nice way of notating your solutions, it can actually drastically aid in making it clear and simple for the reader to understand. So that's also, it's worth taking the time to come up with good notation rather than just vomiting a load of Greek all over the page, right? Yeah.
I agree with that. So maybe we take a last question from the audience. There's one by Adrian Lehmann. What do you think are some good ways to get feedback on papers before submission?
Oh, so the easiest answer to this is send it to colleagues. I mean, in particular, colleagues at the same institution will already be conflicted with you, so they couldn't possibly be in a position where they'd be reviewing your paper. So send the paper to your colleagues, any colleagues who might be interested, and just ask them, nicely, if they have time, to just take a look at the paper and give any feedback. That's definitely one of the best ways to do it. Another way to do it is to even just to, if you're a student, to share it with fellow students. This has always been valuable for me when I was a PhD student as well. In terms of getting feedback on papers before submission, you do have to be careful in the sense that you don't want to, well, if you submit a paper, you don't want to end up excluding people who might be reviewing that paper in a double-blind setting. So you don't want to unblind yourself unnecessarily. So do be careful about that. But otherwise, I think just share it far and wide and let people read it and see what they have to say.
Okay, so we have more questions, but unfortunately we are out of time, and I kind of try to stick with the break schedule so that people who are there in person can go and get a cup of coffee or tea. So Liam, thanks again. I can tell that your talk was greatly appreciated. There seem to be many questions still left, so maybe you will be able to answer or willing to answer a question by email. Thank you so much.